Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me as always is co-host Johan Oberg. Johan, what's going on today?
Hi, Chris. Great to be on again. Another week, another show. Really had a great weekend as well. Thank you very much. We had the opportunity to spend some time with the Insider's Guide exploring the Swiss mountains.
It was fantastic putting the pictures out. I don't normally put personal pictures on my LinkedIn social media, so the two of us skiing, we definitely got some feedback and comments, so that was kind of fun that people saw that we actually hang out other than interrogating and talking to our guests on the show. So that was kind of fun.
For sure. But apart from that, I think you can easily tell the year is kicking off. You know, we go fiscal year. Now it's full steam ahead with some COVID changes, of course. As all of us on the European market, we just realized that eWorld, the big fiscal event, is changed until June. So I hope we can catch up with some of our listeners in June rather than in February.
I'd expect to be live there in June, and by then we'll have some other personalities on the air. I think we'll have our new show coming on. Our analytics show will be out by then. There should be a lot of interesting things taking place. As this is going on the air, we should just be winding down our ETRM mini-series, and you're listening to this. We had to add some additional episodes. We had so much traction that people reached out to us and had their favorite vendors, and they had a couple additional vendors that we're going to be adding. That's going on. And we have some guests, some users. So we're going to have an episode on the main show here where we talk to some users of ETRM and get their feedback. It's been an interesting learning curve doing a mini series because I apologize to you, our listeners who really aren't into ETRM, because there's about 15 or 16 episodes just on ETRM. We're back to normal here on the main show. So please forgive us for that. If you don't like ETRM, and if you did, go ahead and like it and share it. But I really want to talk about today's topic because I've been dying to have something with geothermal on the program. I think I asked Luca, our producer here, I said, help us find someone that does something interesting in this space. Personally, I like it. I had it in my home in North America. I went out and researched it and had that all put into my house because I thought the value was there doing it. But I wanted to talk to a scale of the energy market and the energy podcast. And I think Luca did a great job delivering and bringing an interesting company in today.
I agree. And I think, as you said, from our houses, and in Scandinavia, I think the same thing in the US, using geothermal for your house is one thing. As a frequent flyer and a frequent guest also to some events and on Iceland, you've seen it kind of hands-on on another one. But really, I don't know too much about it apart from this. So I really look forward to getting really the amateur view of this. What is it? What does it do? And actually, what is the development of this? Because it's sometimes old technology as well.
Yeah, I think so. And I think these guys do it pretty cutting edge. I kind of get the drilling angle because they come out of Alberta, Canada, which doesn't seem to be a geothermal hub to me. That's not the first place, but certainly if you're going to drill and do things, there's certainly expertise there. So I'm looking forward to hear how the hell do you end up in Alberta, Canada and become geothermal specialists. But rather than us talk about it, let's go ahead and bring our guests on board. Today with us, we have Alex Vetsak.
Hey, guys.
So tell us about the company. We've already let out of the bag that you're something with geothermal. What does your company do?
Our company is a geothermal startup, or we should call us a geothermal company operating in a startup mode. We are trying to bring a new way to develop geothermal resources worldwide. So, and commonly geothermal is associated with some shallow installations, kind of like heat pumps for house heating, or just kind of like very tiny something in your yard. or you have unique projects which are located in very unique places like Iceland or some hot springs areas and so on, where our idea is that we should bring geothermal as geothermal anywhere. So which means that wherever you live, so like you have this heat underneath, and you can get access to that. And of course, the main question is it feasible technically, economically, and that's what we're introducing in Eavor.
So when you say bring geothermal everywhere,
Right.
bring geothermal to who for what outcome?
To any single household or any user, and that comes to heating or cooling. If you just need to heat your house or cool down your facility, and then of course power generation. If you need to drive your electric car, if you need to charge your iPhones, laptops, or whatever, it's like so. You need electricity, and you can generate electricity from geothermal heat, which
Okay.
means to everybody.
Okay, so the generation then to charge my car, I've got it parked in the driveway and I've got my charger in the garage. This is done then at a distributed level. So you would put your own geothermal system into your own property and charge your own car, not relying on the grid then.
It can be done both. And this is the beauty of Eavor Technologies. We're thinking about large-scale power plants, which would generate megawatts or gigawatts. But then you would also want to have something which is more like off the grid or behind the fence system, and that would be a small scale, which would generate a few megawatts only, and that can be done for a local community. So if your yard and your power consumption is over megawatts, so like then of course you can install your own system. Well, I'm joking, but in general, so you can go as small with 5 megawatts electricity, right, which would probably power a small community or a neighborhood. And then you can go to hundreds of megawatts, which would power a large city with millions of people.
But does that mean that you can do it for any kind of size? You mentioned smaller, larger, from almost a grid scale to residential. Where do you draw the lines? Or is there a one fit solution for everything? Sounds magical.
That's a very good point. Honestly, for us, the biggest differentiator for us would be dispatchability and the scalability. So, which means that the system itself is relatively simple in terms of drilling and completion. That's why we are not trying to bring something new, unique, where you need to work hard 5 years to invent this thing and prove it in the field. So that piece is covered. So like, and then what do we do? So like, we just drilled a subsurface radiator, and that radiator just circulates the fluid. So the fluid goes in, goes out. So on the way down, it's cool fluid, and then of course it's cold fluid, and then of course it will heat up while it's going through this hot rock subsurface. And when it goes up, it's hot fluid, and it's hot enough to be used as a power source or a heat source to rotate turbines on surface. And these turbines will generate power. But if it's not hot enough, so like then you can use it for district heating. And again, depending on technology on surface, you can convert it to either power or heat or cooling or like cold air for your conditioning needs. So that's in the nutshell. And talking about scalability, so we don't depend on any specific aquifers. We don't depend on geology. We don't need to frack these wells. We don't need to kind of like to install them in a very unique place in terms of subsurface, right? So like that's what we don't want to do. And also we can go with a small system, which would consist of a few wells, and then it will generate less power, of course. And then if we see that there is a demand for more power, we can add those loops and think of them as stackable Lego pieces. So you just add, so and that's how you grow your system. Of course, you can start with a little bit larger system in the beginning, but again, it will be just a larger piece of Lego. So, and then you just again stack, and that's how you get up to hundreds of megawatts in the same place. Now, dispatchability is another thing. Usually with the conventional geothermal reservoirs, you cannot, or wells, you cannot stop production. So it will produce all the time. There's no kind of like way to just, unless you want to shut down the plant. So for us, the system doesn't have influx of fluid from the reservoir. So we're just circulating our own fluid in a very closed system. And this fluid obviously can be stopped. So you just choke the valve on surface, you stop that, you let the fluid heat up, or just um, mm, bring more heat into the system subsurface, and then again when you need it, so you turn the valve on, so like the fluid will kick on, it will start flowing on surface, and you have more energy or more heat concentrated in the same volume. So that's how you kind of like build up the um, the energy, let's say, or harvest more energy when you need it. So, and that works really well with some regions where your demand is either sinusoidal or follows some duck curve, and it goes or peaks up in evenings when people come back and they plug in their electric cars or do whatever so they need, and that's where you would want to generate more power. And if you are combining these systems with some other conventional, renewable systems like solar or wind, then of course, if your sun is down, you have less energy. So now you can use this one as either your booster or the base load, or even consider that as your battery. So where you would want to store more energy during the day hours and then just bring this energy up in the evenings.
So
Whoa.
sorry, Johan asked the question, but I have to ask because he wanted to speak. But if you can produce the energy, why do I need this as base? Like, why do I need the wind or the solar if this can be on all the time, right? You can stop it. I get that. So are you just saying because when the load drops, that so the wind or solar will be so much more that in the low peak non-peak times, this is the base load is why you would do this?
Oh, guys, come on. I listen to your podcast, so you can answer this question easily. Solar and wind are progressing in big steps. And obviously, the cost of energy in some regions using solar systems is way cheaper. So, but again, if you go 20 years back, so it was not that cheap. So the same with geothermal, or at least with geothermal systems we have. So they're not that cheap as solar panels today. And obviously you would want to use the cheapest source possible. But again, so if you're living a little bit north, if you have more clouds as usual in your region, so then of course solar is not the best option for you. So you would want to rely on something more base load or more reliable source, which is
Cool.
always with you.
Thanks.
So here's probably a stupid question, but I have to ask it from based on the technology that you mentioned. So if you use this as the power on and off, so basically you're running solar during the day or wind, and you use this as your base load or as your battery, as you mentioned. That means that you hold the water, if I understand it, in the system for a longer period of time. Does that mean that it heats up more, or do you get the same kind of heat coming out of the water if it's constantly rolling?
It will it will heat up to the point where it has like the maximum density, right? So which means that you will not be able to to heat it up continuously, but it will definitely heat up to the temperature of the environment, which is your subsurface rock. So and then again, you store that there, and it's sitting there, so and it's ready to be consumed. So and when you turn it on, you will have like the maximum capacity, call it, or the maximum density of energy going up.
Cool. So now I know that we're talking to you tonight from the road, that you're going all over the world and working on these projects and things, and you happen to be in the North America and US today. So are there legislations? Are there like EPA constraints or other constraints from drilling in different markets that you've come across? Is that a gate or a hurdle that you need to overcome?
They do exist for sure. Each jurisdiction has its own rules and permits. Historically, drilling wells, developing resources in North America is easier than in Europe. I cannot speak about Asia, but we haven't seen any like roadblocks for drilling geothermal wells. Apparently, geothermal wells were drilled decades ago, and governments of different countries um, try to develop geothermal resources they had, and that's why they built those frameworks. Not all countries have them, but more and more countries are introducing them as a localized kind of like regulations. Now, obviously, if they add oil and gas drilling, they will take that one as the template. If they had other um, drilling industries, would it be mining or something else, they will take that one as a framework. Um, but it works, and no, we don't see any issues with that.
Cool.
So in terms of, we spoke a little bit before in terms of the financial modeling, in terms, the investment upfront, etc. So would you say, how is your customer financing this, or how you finance this? Is it through um, subsidies, or is it through PPAs, or how does this work?
I can help with that one. So it works both ways, actually. So like we will develop our own resources, call it, right? So like so, and we will produce and sell this energy to the grid or to the client. But we don't want to own that to ourselves, right? So like and develop one at a time. So like which would take probably hundreds of years before we can do anything serious. That's why we would want to provide this license, this technology to other operators, to other companies, and they will take it and build those plans either in parallel with us, or maybe even like scale it faster than we can do.
So have you already been brought into some other projects? So where there's a PV project or wind project to help do the base load, have you been incorporated into some of these other larger programs? Or are you talking to folks about doing that as being part of it?
The answer is yes, we do talk, we do discuss, we do provide some feasibility studies about that. And clearly it is feasible, it is doable. The question is when? I don't know.
Okay, so it's off the shelf parts. So the turbines and everything like that is stuff that's, well, I think we started the show by saying you're using existing technology, and it's your technology to understand how to put the loops in it is the key differentiator. Is that what I'm hearing you say?
Yeah, that's correct. So like it's when we started this um, company, we were thinking about simpler ways to, of course, to develop that. But more we went into this geothermal and more we understood that, so like we realized that there's a gray area, or let's say the technology which is not directly available, but also like so the unique way of building our geothermal systems can be protected. So it's a combination of actual technologies, methods, processes. So like we're trying to combine that all together, and we're also working with various partners developing some missing pieces or optimizing those which are not super optimized for us. The cost of our systems is high to it's like an intensive or capital intensive project. So, but once you build it, so the operating cost is low and the lifetime or life cycle is pretty long. So, which means that you would want to protect that initial capital investment. And when we license that, so we demonstrate what can be done in the beginning to drill or to build these systems in the most efficient way, because once you spend this capital, so like you know that there's kind of like minimum cost to operate those things. On top of,
yeah, sorry, go
sorry,
ahead.
just one more comment. On top of technology, licensing technology, so like we're also, of course, trying to provide this service, how to build this first loop. And once this one is built, so like then the next one will be probably overtaken by like local teams or operators to continue building.
So the operations will then be managed by whoever then
Correct.
licenses it. Okay. So if we roll forward a couple of years, I don't know, a year, 5 years, whatever, the technology is proven, you've started your installations, you have the fundings. Now I put my marketing hat on and see, okay, but what segments are we then starting to go after? Because obviously you have a broad opportunity here to go after everything from the renewables to the municipalities, to utilities, even all the way down to the consumers. But where would you see are the kind of I wouldn't say the low hanging fruit, it's probably the wrong word in our industry, but where would you see the segmentation once you start going commercial? What will be the initial ones?
I'll take this one, Mary, if you don't mind. So for us, the low-hanging fruit would be markets where prices are high, thermal gradients are high, and the cost of drilling is relatively low. Because most of the cost is coming from drilling at this point. Of course, you would want to get the highest prices for your product, obviously. And if you think geographically, there are some places in the world, and Germany is one example, where all three things combined are working in our favor. So, but Germany is not the only place where you have those. So you can get a combination of two of them. So North America is a good example because you have like a really high thermal gradients in the West US. You've got drilling technology, mature and relatively inexpensive compared to other markets. Prices are not good, but you should find the way or the space where the price would be um, attracting. So islands, they have, especially volcanic islands, they have high thermal gradient, they have high prices because you compete with diesel or coal or some other means. But the cost of drilling will be pretty expensive because it's a remote location. You need to bring everything else. So honestly, we have people working with different entities worldwide, and the most recent development is in Singapore, where it's a very interesting request for our technology because this country is relatively small. You would consider that, but they have strong interest to develop Everloops on their land. And then, of course, Japan, the UK, your homeland, would be interested as well. So it's a combination of these three factors.
So that's the geographical point of view I can understand, and the drilling and the rest. But one step further, who is actually then buying this and operating it for you? Is this the utilities that will do this, or is it the large industries? Is it the municipalities that want to go there off grid? Who's actually, once you have all the perfect conditions, who are the first ones who's going to do it in Germany or in in the islands?
Right. So that would be most likely independent power plant operators who would want to, like, who've got expertise, who have a relationship with a local municipality or with local authorities. Potentially, they already have power purchase agreement so in place. So that would be the low-hanging fruit in terms of clients.
Oh, interesting.
Well, cool. So you've described kind of where it goes. How how deep and how much, like you talk about drilling, right? And so to get to the temperatures that you need, how deep are we drilling through? Just layers and layers of bedrock? Are we, we getting down? Like, describe what the drilling process is. I get that there's some intellectual property there, but just in principle, what are you drilling to?
We are drilling. Um, okay, no, because I'm an engineer, right? So I'll start like throwing some
Try to explain it like
engineering
you're explaining it
terminology,
to
right?
me or
So
your
like so,
mom.
right. We will be drilling different formations. That's number one.
Okay.
What combines them is heat, which means that if a sedimentary rock, like a sedimentary basin, has high heat gradients, then we will drill there. If you have some volcanics or some active kind of like zones near to volcanics, right? So like or active
Yeah,
volcanoes.
understood.
So then we will build drilling there. And if you don't have any of those, then we will drill into the basement, which has on average 30, 35 degrees per kilometer Celsius per kilometer
So I
temperature.
guess that's my question, right? So I think the premise of your company, of one of the premises I've heard you say in the value here and doing some research, is this works everywhere more or less, right? There's some places better than others. So
Correct.
certainly if I have a volcanic and I have molten lava just below my feet, that's probably not a very deep drill. Um, but if I'm somewhere not one of those places, it still works. And so my question is, and you said that the cost of the project, what I understood, has to do with the drilling capabilities. So in some remote island where you'd have to ship all the drilling equipment in, you'd have the cost of shipping the equipment, and not the drilling may not be any more expensive unless you're telling you have to go deeper or some other reason. So what I'm trying to do in my mind is kind of calculate this out. So I get if it's a long-term ROI, that's fine. If you look at what energy plants are today, if I put a nuclear plant in, or if I put a traditional coal plant in, or something like that, the project lifespan in the old world of energy was probably 30 years plus, right? So you had time to recoup your investment. Now, the challenge, I think, from the cheap seats is if I look at the distributed plants going in today, the ROI on them are very quick because of the lower cost to go in. And nobody has an idea that, in the time that your facility will continually be pumping energy out, I've probably gone through multiple generations of solar PV, or, and I've probably gone through, my turbines have been upgraded in my wind turbine farm or whatever. And I would suspect that you still have your same core loop in place for a much longer period of time, and you may change your turbines or something like that, but the core expense is already sunk and it's there. So I guess that's what you're competing against. So I was trying to figure out, hey, if you've got to dig so many kilometers deep into bedrock, that's going to be really expensive and really slow. And then the second thing is, if you guys are successful, do you get economies of scale, right? Like the laser disc player, when they first, you first wanted laser stuff in the beginning, it was super expensive. But if a lot of people are putting the technology in, you get economies of scale, and the drilling capabilities should come down in price as well. Is that all
So
logical?
you nailed it down actually. So like you answered your own question, honestly. So for example, unconventional reservoir development in oil and gas started 20 years ago. The cost of drilling was super high and not a lot of players were drilling. And these projects were either supported by the government or they were just a like one-time kind of like project because of regional geology and so on, or some other benefits of developing this. But then more and more players were coming in. Service companies started investing money, in developing technologies for that particular application, and then you saw like a significant decrease in cost. So that allowed drilling more complicated projects, and we call them unconventional. But honestly, so like within this unconventional portfolio, you have tier one, tier two, tier three, and so on. So like of resources, and the cost will be kind of like dependent on that. So we do understand that the cost of drilling right now is high. But if you take this shale revolution in the States, what they call it, right? And you go through like a decade of technology development and cost of services, you can see a significant reduction. So is it following a pattern? For sure. The same happened with other industries. So we would expect that starting um, drilling geothermal projects, you would target relatively shallow and high gradient, but over time, the cost of drilling per kilometer, per location, per Everloop will go down significantly. That the drilling cost will not be that major contributor to the overall capital of the project. So that's where you would start optimizing other capital costs, which applies to surface facilities, to the connection to the grid, and so on. And you can drive it down as well. So working on all of that, so like you can drastically decrease the cost, the capital cost of drilling. So, and again, you would probably calculate the levelized cost of electricity in this case, or would you count for capital spent per megawatt or whatever it's like. So it doesn't matter. So like some metrics, but it will go down for sure.
Cool.
So we discussed on this show quite a bit in terms of renewable energy, as you probably heard before. And one of the things, for example, always comes up when we talk about wind is, yes, everyone wants wind, but not on my backyard, kind of an attitude, which is one thing. Out of curiosity, when it comes to your kind of services, facilities, and the infrastructure needed, what are we talking about? Most of it's underground, so it won't be noticeable anyway. That's one thing. But surely there's something above ground that needs protection areas, buildings, etc. What are we talking about size-wise here?
Have you ever been to Singapore?
Never, but I
I haven't
sure
been
would
there
like
as
to.
well. No, like neither me, neither me. But what I
Brandon
heard,
back. Thank you.
yeah, what I heard that so the land there is super expensive, and even if you have money to buy it, you will not get it. Why?
Mm.
Because the land is super expensive, not in money cost, but like in resource cost. So that means that you have to find a way how to use or to have the smallest footprint possible. And solar or wind are not the greatest options for that, right? Well, we all know that. So with Eavor on surface as a geothermal power plant, it will have a small footprint compared to other things. But again, if you want to have it in your backyard, that's still big. Uh, Another option is that you can actually, with geothermal systems, you can also put your power generation facility underground, and that's a solution for countries like Singapore, where they don't want to have anything on surface. They want to have a park instead of a geothermal plant. So that kind of like tells that your footprint could go from relatively small compared to other power generation facilities to nothing. Does that answer your question?
Well, for sure did. For sure did. And it's an interesting approach because this is obviously one of the key factors in anything we do in large scale energy production. You know, I work in, or we both work in a country that is big on hydro. And when we see the big hydro dams up in the mountains, those are not small installations. Those are quite massive. You look at solar farms, wind farms coming out of the Nordics and on the seashores, it takes up a fair bit. So it should be an appealing approach, I would assume. But coming back a little bit, Mara, maybe to your discussions that you mentioned before, we talked about the investments in terms of financial, if that's solved by PPA or in other subsidies, but also you, as a company, you had some new investors coming in, and two of them kind of caught my eye a little bit with Chevron and BP, and it would be just interesting to if you have any input on what are their kind of is this a pilot thing for them? Is this part of their renewable? You know, why are they investing in you guys?
I would add to this one, and I'm not hijacking your turn, Mar. So I'm just I would add that companies like BP or Chevron, they have all core skills already
Mm.
developed to switch to geothermal drilling or geothermal development. Think of those energy companies. They know how to drill wells. They know how to produce resource on surface. They know how to process that on surface. They know how to ship it to whatever location, but they also know how to sell, so how to trade resources. Like they're so fit for purpose. It's an easy switch for them.
Yeah.
And because we're not talking about geology as the core kind of like for them, so like of course it is important, but like for them it would be a relatively easy transition from sedimentary rocks they were developing worldwide to geothermal specific, right? So like would it be igneous or would it be sedimentary with some heat? So you're pretty much just replacing this oil and gas or other hydrocarbons they're developing with heat. So there will be harvesting this heat, producing that, so selling that, so like in terms of thermal energy or electrical energy. So yeah, that's why that's super attractive
Yeah.
and it's scalable. That's important for them because before they were looking into geothermal power production or power generation, it was not super scalable. So now with this technology, it's scalable. It can be built worldwide, and for them as a global company, so like they would definitely want to do that.
Well, very cool. We're starting to run out of time. I do have kind of one last question for me, and I'll let Johan have one more at bat here because I know he's got plenty of questions, as do I. So I know you talked about why these hydro companies or hydrocarbon companies would be interested in you, and I think the core technology also brings over. We've seen this in marine, we've seen this in other industries where they invest, where they have some core competence that help accelerate perhaps. But my analogy to the marine energy industry is that a lot of them get together because when the tide goes up, all ships rise, right? And you need those economies of scale. So, are there other groups that you work with? Is there a geothermal like effort that you're a part of that you're jointly trying to get this to go, or is this just a free competition? Like, have you partnered up with others to help get the message out for this kind of a technology, even if your intellectual property may be different? Is there some economies of scale there?
We do work with other geothermal, other companies, or even working close with regulators, with associations. Would it be international? Would it be North American Geothermal Association, which is Geothermal Rising? You guys might be aware of that. And obviously, we do work with other geothermal operators who have an interest in this technology because sometimes like so you have the lease or you have like a power purchase agreement you would want to fulfill, but you don't have the right resource to do that. So that's where you would want to bring some other technology which would either complement or enhance or just scale up your power production.
Cool. Johan, any final questions or thoughts?
Well, first of all, thank you very much. I thought this was really interesting. I came in very novice, and I picked up a fair
You're
bit.
still very
of
novice,
this.
by the way.
I know it's great, isn't it? But one of the things I was just curious about, we're in January 2022. What are the main thing to look forward to this year for you guys? What's going to rock the boat a little bit for your technology in your company in 2022? What are you looking forward to?
Yeah, so I'm hoping to continue in this to work in this startup mode, so like where we're supercharged, so like we work as a team, so super efficient, I would say. So we're growing fast, even in those pandemics kind of like or COVID related timings, right? Or times. So and our team has grown probably like 2 times or 3 times, Mary, exact number, right? We were continuously testing our technologies, developing new technologies. So it's an ongoing process. So we brought more investors in the last 2 years. We've got more projects outlined or already kind of like in that feed stage worldwide. So we have a real test well here in the North America, and we plan to build like first stage of a commercial project this year. So if you kind of like put this all together, 2022 is super exciting year for us. If we kind of check mark all of our targets, that'll be awesome. So like if we check mark just one of them, that'll be awesome. So like, so just to work in this team is awesome.
Well, awesome. I have to say, Mara, Alex, it's been amazing for me. I think it's been fun. I feel the passion coming through. It's contagious. That's the fun part about being in young companies is you got that energy and the drive to do what you need to do. I thank you so much for being our guest on the show. I look back to check in with you guys again in the future to hear about your commercial project. I want to hear about that big win. Don't forget about us when you have it, because we definitely want to make that out to our audience, because it's exciting times. It's exciting to hear that. So thank you so much for being our guests.
Truly appreciate it, this invitation and this time, guys, with you.
Well, thanks again for our audience. You've spent another hour listening to Insider's Guide to Energy. We hope this first entry into geothermal energy has given you a lot of things to think about. And perhaps if you're in a position to either invest or to make these kind of decisions, reach out to our friends. And we will talk to you again next week. Bye-bye.